Hey guys, welcome to another video on sketching parabolas. Now, in this video, by now we have covered every single transformation you are going to encounter in terms of parabolas. We've talked about dilations, we've talked about reflections, as well as vertical and horizontal translations. Now, what we are going to be looking at in this video is when we have to do more than one transformation. Now here I've written combined translations because that's going to be the bulk of what we're doing, but every single question we're going to do here is going to involve some kind of combination of any two or more parabola transformations. So a reflection or translation or something like that. Now, in all of these videos, we are going to start to think about doing this a little bit more freehand and quickly. So this is going to work on our efficiency using our conceptual knowledge of all of the transformations and what they actually mean. And instead of drawing up a table of values, we are going to sketch these parabolas, and all the questions will require you to do, at least for this first batch, is to show the y-intercept and the coordinates of the turning point. So for all of these ones, we just need our y-intercept and our turning point coordinates. So let's just jump straight in, and all of our questions that we're going to be doing, they're going to be centered around our original y equals x squared parabola. When you do these, you don't have to do it this way, but I've always have found that having this as a starting point, knowing, well, what is my easiest foundational parabola that I can just kind of know off the top of my head, this y equals x squared one, and I can transform from the perspective of this one. Because everything we've been doing so far has had this guy as our starting point every single time. So I like to keep this, even if you don't draw it, I like to have it as a little mental starting point for where I can transform from. Because in essence, we are transforming all of our parabolas from this kind of foundational equation here. All right, let's look at example 1. So in question 1, we want to draw y equals negative x squared minus 1. So before we even go into drawing anything, we want to consider, first of all, what are my actual transformations going to be? And we want to make a note of these ones here. So I have here y equals positive x squared, but here I have a negative. And my negative, as we've learned before, this implies a flip, a kind of reflection around my mirror here. Remember when we looked at parabolas, we were talking about this, the idea of the mirror that we reflect along is going to be our x-axis, or the line y equals 0, which is just another way of saying your x-axis. And here, what else do we have? Well, we are adding a constant, or we're subtracting in this case, a constant from our reflected parabola. So this thing here, and we've got to think, what type of shift is this? What type of translation is this? Well, we are looking at a vertical translation. So anytime I'm adding or subtracting a constant, right at the end here, that's acting on the y. So it is going to shift my parabola up or down. So now that I've made a note of all of these, I can start trying to reflect my parabola. Well, sorry, not reflect, transform my parabola. But we're going to start by reflecting it. So this guy here, I'm going to draw this first as just a reflection. So I'm going to reflect, let's do that a bit nicer. I'm going to reflect all of these points here. So this actually just looks really bad. Let me just try to draw that again. Okay, it's as good as I can do. Now here we have reflected all of our points here. So if you notice, this point here is reflected perfectly down here. So that point becomes -1, -1. And this point here gets reflected down here. My vertex of my parabola, or my turning point, that is right on my mirror reflecting line, so that point's not going to change. This point has gone down to here, and this point up here has gone down to here. So I have done the first part of my transformation. Let's actually, I'm going to do this in the same color as I've written up here to show you the kind of progression from transformation to transformation. Okay. So this guy here is my reflection. I haven't had to do anything crazy. I've just had to reflect this parabola, make a mirror image along this line here. And now I want to work with my vertical translation. Now this guy is negative. We have -1. So in the y direction, that means we are going down 1 unit. So my vertex here, or my turning point, is going to go down 1 unit. Down here. So my new parabola becomes, oops, something like this. And this is my now vertical translation. Okay. And I just want to find, just because we need to give a couple of points for scale here, I want to just find my y-intercept and the coordinates of my turning point. So my y-intercept is just where my line cuts through the y-axis. So that is going to be at -1. That's my y-intercept. And we notice my turning point is actually at that very same point. So the coordinates of my turning point, I have 0 in the x, because remember, I've just translated down from this 0. So my x coordinate stays the same, 0. So because I'm translating down, my y coordinate is going to go down by 1. So I get -1 here. So that is all we need to do for something like this. Now you can try, if you'd like, in finding your y-intercept. If you'd like, at home, pause the video and just substitute in for when we have a y-intercept, that's when x equals 0. So if you pop the space of this x, you will see that we can figure out numerically that this is also going to be a y-intercept of -1 down here. So this is how we can break this down and work with 2 different types of transformations. And we're going to do a lot more examples, so if it's not making sense yet, please feel free to join me for a few more. Now I'm starting again with my simplest parabola, y equals x squared, and in my second example, I want to sketch, I should say, of y equals minus x plus 2. So, center this. First of all, we notice we have a negative in front here. We have my negative in front of my entire expression, x plus 2 all squared. So that automatically, once we have a negative there instead of a positive, implies a reflection. And now I can see there's another constant, another number, but it is acting on the x. It is inside these brackets. It's not outside here like the previous example was. So this thing here implies a horizontal translation, a translation in the x direction. Okay, so we are going to once again just draw from the perspective of my original parabola. So I have a reflection in the exact same way I did with my last question. So I'm going to just reflect this guy down here. And let's actually write reflection here. And I'm going to actually want to translate this in the horizontal direction. Now my sign in front of my constant 2 here is positive. So remember, whatever that sign is, we want to translate in the opposite direction of that. So this actually means that we're going to translate this 2 units to the left in the negative direction. So each of these points are going to shift 2 units to the left. So I'm going to draw my new turning point here. What are its coordinates? Well, it's going to be -2 as my x coordinate and 0 as my y coordinate. And I'm going to draw this parabola down here. And this here is my horizontal translation. Okay. Now, if it's tricky for you to remember this type of stuff, where whatever the sign is, we go in the opposite direction for a horizontal translation, you can always calculate this by finding the x-intercept. You can do this like we did in the previous video. And if you'd like, pause the video, have a go at that, and you will see that the new turning point or the new x-intercept is going to be shifted 2 units to the left. And now, just for scale, I want to also calculate what my y-intercept is going to be. So we want to find my y-intercept, and we know we get my y-intercept when x equals to 0. So if I have my equation here, I'm going to put 0 in place of x. So my y equals -0 plus 2 all squared. And that means I get, let's do these brackets first. So 0 plus 2 gives me 2. 2 all squared is 4. So that's like saying -2 squared. So 2 squared is 4, and we keep the negative in front, so that gives me -4. So that's going to be roughly, my y-intercept is going to be about down here at -4. Now I haven't really drawn this nicely to scale, but on a proper grid, you will get a much nicer thing. But also, once we get to sketching these parabolas, remember when we sketch something, it's just a rough outline of where everything goes. It doesn't have to be picture perfect as long as you have put your points in the right place. So something like a turning point, you're going to want to get that exactly where it's going to go, and you're going to calculate your intercept as well. So as long as your calculations are correct and you've drawn it roughly in the right place, you're going to be okay. Okay, so that is how we can think about combining some of these now. And we can see that every single time we're spanning out of my original y equals x squared parabola. And we are doing one by one all of these individual transformations to get a new parabola. All right, let's do a couple more. Now here we're going to be combining translations. I'm going to work through these a little bit quicker because hopefully by now you've got a better idea of how these will go. So I have my y equals x squared once again, and I want to find the equation, I want to sketch the new parabola for y equals x minus 2 all squared minus 1. So let's look at what we have here. Now, there's no negative in front, so we're not going to have any reflections. Have our original orientation of my parabola, kind of like this. We're going to keep it concave up. And I'm going to start looking at what I have here. So this guy here, close to the x, this guy is going to be a horizontal translation. The translation is acting on the x, it's pressed up near the x, so we know it's going to be horizontal. And my -1, that is kind of outside of the x out here. So it is acting on the y here. So I have here another type of translation, but this time it is vertical. This is a vertical translation. Okay, so let's just do these one by one again. So our horizontal translation, that means, well, my sign here is negative, so I am going to be shifting 2 units to the right hand side. You can also test this by finding the x-intercept, but because we're working through these a little bit quicker, I'm going to draw in my first kind of iteration of my parabola. So it's getting shifted 2 units to the right hand side. That's what this constant is telling me. Remember, we're shifting by however many units this number is in value. And I have a negative here, so I'm going to be shifting this down, because with the vertical translations we go in the same direction as the sign. So I'm going down by 1. So that means my turning point here at 2, 0 is going to get shifted. Let's do this in the same color. It's going to get shifted down 1 to here. So I'm going to get 2 and -1. And now I can just draw roughly what that's going to look like. So this is my translation here. I can see I'm just translating from the vertex. That's the easiest point, but all of these points are actually moving here. So we can see I've gone 2 units to the right, and then I've also gone 1 unit down. That's given by this negative. So I've actually I've moved -1 units in the y direction. So each of these points are moving here. But I'm measuring this from my vertex because it's just the easiest place, or the vertex or the turning point. It's the easiest place to think of these shifts as moving from. And this guy here, 2 -1 is my turning point. And now finally, I want to calculate my y-intercept, which I get when x equals 0. Okay, now, this is my equation here. So x here equals 0. So y equals minus 2 squared minus 1. And minus 2 all squared gives me 4, minus 1 gives me 3. So let's draw this again. This is where, like, once you actually calculate it, you want to be a little bit more specific. Whoops, and just show this. But my y-intercept here is at positive 3. And we can map out, let me actually just get rid of this interim kind of parabola that we had here. We can map out how my parabola has been translated and changed. It's gone 2 units first to the right, and it's gone 1 unit down, or negative 1 units in the vertical direction. And our point, all of our points, but in particular our turning point, is going to move based on these translations. Think about it. We've gone 2 units to the right, so we've gone from, first we went 2 units to the right, so we went from 0 to 2, and then we went down 1. So my y coordinate changed. It went from 0 down to negative 1. So each of these points are shifting across as we go, as we do these types of transformations. Now let's do one last question, and this is probably the hardest one we'll get today. Now I want to sketch the parabola of y equals negative x plus 3 all squared plus 2. Now some of you may have picked up on the fact that there is a lot more happening here, because I have a reflection here, because I have a negative here. So I have a reflection happening. I have a horizontal translation happening. And I have a vertical translation. Oops. Okay, so I have 3 different transformations I'm doing here. So this is going to require us to be really careful when we start drawing this out. Now, this is why I like to start from my y equals x squared, because when there's so many things happening, you kind of want to just track it from the most easy parabola we know, and then sort of span out. So first of all, we have a reflection, which I'm going to draw in red. So I'm reflecting this down. I am translating horizontally. So here we have a positive 3. So we want to go in the opposite direction to this sign by the amount of units just being whatever this number is. So now we want to go 3 units to the left. So we're going 3 units to the left. So everything here is getting shifted 3 units to the left. And I'm translating this up by 2 units. So my entire parabola is going to get shifted up. So let's actually just mark in the turning point as we go. So this guy is going to be negative 3, 0, because I've gone 3 units to the left. So it makes sense. My x has gone from 0 down to minus 3. And I also want to go, did that in blue, so let's do it again. I also want to go 2 units up here. So my new turning point is going to be negative 3 still, because my x isn't changing, only my y is changing, and my y is going up by 2 units. So, whoops. Okay, that's glitching out. That's all right. Now that I've shifted this up, just to make this a little bit nicer, let's now draw my final parabola. And that is going to look like this. Now, I can get rid of all my interim parabolas because now I've found what my final parabola is going to look like. But you can see that I've shown these kind of like these vectors we looked at in year 8 geometry. So I'm showing that I'm going -3 units in the x direction, and I'm going up 2 units in the going up 2 units in the y direction, or just positive 2 units in the y direction. So now we have drawn our final parabola here. I've shown the final transformed turning point. Now we just want to find the y-intercept. So I'm going to find the y-intercept by substituting in x equals 0. So my y is going to be -0 plus 3 squared plus 2. Okay, so that's going to give me -3 squared, gives me 9, plus 2 gives me -7. So this guy here is going to cross the y-axis like somewhere down here at -7 units. So like I said, you can even see from my drawings, they don't need to be perfect, and a lot of these parabolas that you're going to be drawing won't look like pristine, but as long as you're just showing a y-intercept for some kind of scale and showing that you understand how the turning point is getting transformed, and in turn how all of the remaining points are getting transformed. But the turning point, because it's being translated twice, it's going to move a couple of different directions, and we just want to show how these movements are affecting both my x and my y coordinate of my turning point, as well as all of the other points here. But that sums it up for these types of combined transformations for parabolas, and I will see you guys in the next video. Thanks so much for watching.